Alright guys, welcome to chapter 5 of the CompTIA Linux Plus cram session here. What we're trying to do here today is talking about storage and how Linux treats storage. Linux treats storage a little bit differently because remember, Linux was designed as a server operating system initially, coming back from the mainframe days, and so it can handle a lot of enterprise level storage and it treats it differently. Now, remember what we talked about everything being a file, and this is nothing different. So today, we're going to differentiate the difference between a block, file, and object storage. We're going to understand MBR and GPT partition tables. We're going to look at LVM, which is partitioning of logical volumes and file systems. We'll learn how to temporarily and permanently mount file systems through the etc fstab file. We'll learn how to navigate through the standard Linux directory structure, the FHS, and then we'll look at troubleshooting common storage issues. Now, if you haven't been in the Linux operating system for long, this section is probably another section where you may have to spend a little extra time on to fully understand. So let's use a library analogy. Let's think of our hard drive as a brand new empty library building. Now in that building we need to start installing things. We need to start putting things in. So we're going to start creating sections and installing shelves within our new library, such as nonfiction, fiction, historical. We're going to have all these different sections in our library. Now each of those sections are going to be called partitions. This is where we're going to start storing books in the future. But before we start putting our books into the shelves in these proper sections, we need a file system. We need a way to categorize and organize the books in each section. So this is what we're going to use, is our file system. Think of it like the card catalog of an old library. In order to find a book, you went to the section, pulled out the card library, the card catalog in the library, and it would tell you exactly which shelf to look at for that book. Now, this isn't always helpful if we don't know what all the labels are in the book, in the systems. So this is where we start mounting things. So we want to put signs up on the end of each one of our shelving units to let everyone know that you're going to find sections A through H here and I through K here, and different numerical systems. And this is what we do with our mounting systems. So we'll know where we put certain file systems and certain partitions by knowing where we mount them. Okay? So the library analogy is definitely one that I like to use here. Think of it as I've got a brand new hard drive, I need to bring in shelves, I need to have a catalog systems, and then I need to be a way to navigate the system itself. So between those, you'll know about partitioning, file systems, and mounting. Now, there's a few different storage concepts that you should know for the Linux Plus, and depending on your need is depending on which storage concept you're going to use. The first one we'll talk about will be the block storage concept. This is the lowest level of blocks. This is very fast and direct types of storage. Think of this as your hard drive in your laptop. It is a attached hard drive and it's a block storage device because we have direct access to the hardware itself. There are going to be times where we just don't have direct access. As humans, I don't know about you, I'm not a very good person of just reading binary. So I need a file storage system. So I would use things like folders and files and be able to navigate through it that way. So through file storage, through my file system, I'll be able to navigate through all of my files. Now this doesn't necessarily mean that it's local to my PC. This means that it is human friendly, but could be either on a network attached storage or on a different server entirely. Now lastly, the third type of storage concept that we'll talk about is object storage. Object storage is pretty new, at least when it comes to consumer storage, but pretty common now. Most of you probably use OneDrive or Google Drive or anything like that Well, you're using object storage. Object storage is flat bucket space where data is stored as objects, and it's normally infinite. It really doesn't matter. Behind the scenes, yes, there are servers and storage arrays and everything that handles them, but you as the user don't care. You are just going to throw everything into a bucket and let the object storage array take care of it. Now, this is a lot of cloud storage. This is where you're going to find a lot of cloud storage is through object storage. So let's go back to what are partitions. That partitions the shelves in our library is that logical division on the physical drive. We normally like to create partitions within our logical drive to help us organize data. Maybe we create a partition for our operating system, another one for user data, maybe another one for my games. I don't know. Whatever partition we want to split it up in. It could also be used for dual booting to have multiple types of operating systems within our system. Because certain operating systems have different partitions and file systems that they need, we may use a partition to separate them. Or lastly, we may just use it to improve safety. In case one partition gets corrupted, the others are not affected. Now be aware, just because they're on a different partition, they're still sharing the same physical disk. If that physical disk does get destroyed, all partitions on that disk are now gone. Okay? So just because you have them in different partitions doesn't mean that they're 100% protected. Now, the partition table on the disk itself helps us tell where each partition lives on the drive. It basically tells us where it begins and where it ends. Think of this like property lines. Think of this as your property versus your neighbor. How do we know what is your property and which one is your neighbor's property? Well, we use it as addressing. If my address is this and their address is that, then I know that we're talking about two different partitions. Now, we do have partition types on our system. We have the first one, which is called the MBR, the Master Boot Record. This is the old standard. We used to use MBR quite often. It's basically a single line of text that lets us know where these partition tables live, to let us know where they live on the disk. Now, the problem is they were very limited. They limited the amount and size of our partitions. We can only go up so large because there was only so much addressing that they were allowed to do. So we came up with a new standard. The GUID partition table, the GPT table, which allows us to have larger partitions, is a lot more flexible, and it's safer because now we have redundancy built into these records. No longer do I need to worry about just a single record that can get destroyed. I can now ensure that I can, for one, use larger systems. It's going to be more robust, and it's definitely going to be a little more redundant. So as I said, those MBR limitations had 2 terabytes. 2 terabytes was the largest partition we could have. Nothing could be larger than that. Now, it also limited how many partitions we had. We can only have 4 primary partitions. Now, there were ways to extend them, but it was clumsy, it didn't work well, and hope that they didn't get corrupted, because if they did, you could say bye to your data. Okay? Now, we'll still see MBR quite often, and we see them on USB drives. The reason why we use them for USB jump drives is because these little drives are really great to install operating systems on, but they do not need to be so large. And the reason why we do it is for backwards compatibility. There are some systems that just do not support GPT, and so using MBR allows us to have that backwards compatibility. Now, we can use GPT nowadays. Supports disks up to zettabytes, trillions of gigabytes, so the size limit is pretty much not a factor as of today. I always like to say as of today, because who knows what we'll grow into tomorrow. We do have a 128 partition limit. I don't know about you, I don't need that many on a single system. And it also has resiliency. Remember, I was telling you about that partition table. It does also store a backup of the partition table at the end of the disk in case it needs to be recovered. Just because it gets corrupt doesn't mean that the entire partition is going to be corrupt, unless maybe the whole entire drive dies. Okay? Now, we do want to say this is our standard for all modern systems. So if you get asked this on the CompTIA Linux Plus, know that GPT is the current modern standard, but sometimes they like to trick you to say, what type of hardware would you, or what type of partition type would you use for this 1 terabyte drive on legacy hardware? The legacy would be MBR, while new would be GPT. There are a couple tools that you should know about for creating partitions. The first one is going to be fdisk. This is classic interactive menu driven tool. It's reliable, it's universally available pretty much on every operating system. I like it a lot. Just be careful with it because you do need to use sudo with these commands. And if you do delete your disk or corrupt your disk, again, I hope you have really good backups, okay? These are tools that you can use to help with the disks, but there's something that you can really mess with the system as well. The other tool would be Parted. Parted is another more modern tool that can be used. It's interactive, definitely command line again, but Parted works better with scripting. So if you're going to be using automated scripts, Parted is the way that I would go. If you're doing one-time uses, I like fdisk personally just because it's what I'm familiar with, but both tools work really great. All right, the problem with standard partitions, they are rigid. Once you create a 100 gigabyte partition, it's really hard to change the size of it, whether or not you want to go bigger or even smaller. So be very careful with starting standard partitions, because that's why we came up with logical volumes. Standard partitions are very fixed, while logical volumes have a abstract layer between the two. So we can actually change things incredibly flexible, actually, with the way that we store our data. You can actually grow partitions really quickly and easily, and sometimes even shrink them, which is really cool. It's one of those technologies that you can't do with a standard partition. So LVM itself even allows us to go across multiple hard disks. How crazy is that? There's not very many software partitions that will allow us to do that. Now, this is one of those things that I do caution you on. While just because you can isn't something that you should do, okay? We all know what RAID is for those who have taken the CompTIA Server Plus, so you know about resiliency and fault tolerance and how we built that into RAID controllers. This is not that. This is a single partition spreading across multiple hard disks. If you lose a hard disk, sometimes LVM does not like that, okay? Hopefully whatever files that were on that disk weren't that important to you because now they are gone. So again, one of those backup things. I normally don't like to go across multiple hard disks unless I really have to. I'd rather go through a RAID setup and then use LVM on it before I span multiple disks with this type of file systems. All right, so the LVM paint bucket analogy. Here's something that I do try to tell you about. Imagine you have 3 1-gallon paint cans. These are your hard disks. With standard partitions, you can only use one of them at a time. With LVM, you can pour all 3 cans into one giant bucket, and now you can have one giant partition. If you buy a new can of paint, you can add a new disc to it and just keep increasing size. It is cool. It's just one of those things that is not the be-all solution for everything, okay? Just be aware that LVMs are great to like expand and shrink partitions on the fly. Just don't use them too much for your redundancies. So there are different components of the logical volume management groups. You have the physical volumes themselves. These are the raw building blocks. These are the disks or the partitions that we assign to it. We have the volume group itself. Think of this as your storage pool. This is where all of the physicals get combined. This is that one giant bucket that you get. And then lastly, we have logical volumes. You know, which one is for OS, which one's for apps, which one's for Joe in accounting. Whatever you have, each slice you take out of the logical volume can be like which paint do you take out for a special job. I like to say this is one of those places where if you want to split up to logical volumes because it's easier to manage, this is one of those things that you can split up all of your storage pools into smaller groups, so that way, for one, we can have security across all of our storage arrays. It's a nice way to segregate different data points from different other groups because they're completely a separate volume, a separate mount point that it's easier to secure. Now there are a few LVM commands. There's the PV create. This actually does the physical volume itself. This is the first one we do. Once we have a physical volume, we can then create a volume group. And once we have a volume group, we can create a logical volume. Now, once you have a logical volume, this is great. Now you can do different things with it. Like we can resize it by using LV extend or resize 2FS. Resize 2FS is basically saying, okay, now we can tell the FS, we've resized you, here's your new home. It's almost like buying my neighbor's property and then expanding my backyard into it, okay? Just by buying it doesn't expand it. I need to take the fence down and allow the file system to know that it's been expanded. By doing resize 2FS, this resizes the entire file system, so that way it now knows the entire logical volume size. Now you keep hearing me say file system, mainly because, man, it's so ingrained in the back of my head. It's just so easy to say. But anytime that you're dealing with a logical volume that's just a blank slate of blocks, you need a file system to organize it. Remember, it's that card system in our library. If the it's the card catalog to tell the OS exactly where to find a piece of data. Because I opened up a file within a folder, doesn't tell this operating system exactly where it is, so I need to be able to have some kind of system that will organize that information for the operating system, and that's called my file system. Now, the common file system that we'll have all the time is going to be like ext4, long-time default in many different systems. You'll see, ext3 and other ones out there, but as always, just like we do with Windows, with FAT32 and TFS, we're going to expand into new file systems to bring extra capabilities. For instance, we have XFS now, which excels at very large files. We use XFS quite a bit on file servers, same as ZFS. We use both of those quite often. These are systems that you'll find. Now, you'll find ext4 quite often on your desktop operating system still to this day. Really great file system, and it does a good job of handling what we need. Because remember, just like MBR and GPT with our partition tables, we are still going to upgrade our file systems whenever we hit limitations. Now, there is a BTRFS, which is a new modern system out there as well. That's basically a software RAID system. Remember when I was saying don't use LVM as your RAID system? If you used LVM with a BTRFS system, then now we can have extra security systems built in to say we have now RAID, checksums, snapshots, backups, everything built into our system. And these aren't just the only ones out there. These are just the ones that I'm calling out, especially for the CompTIA Linux Plus. Now, how do you manage different file systems? Well, for one, you do need to make a file system. So you need to be able to look at what device it is. And remember, I said everything on a Linux file system is a file. So where are your hard drives? Well, they're under the device directory. Under DEV for devices, this is where you'll find all the devices for your operating system. This is where you're going to find your keyboard, your USB ports, your COM ports, your hard drives, your monitor. Everything is going to be underneath this directory. Now, SDB is your B1 partition, so SD is for your first hard drive, and we got the second hard drive, so it's a B and the first partition. Oof. If you like looking at that, so now we want to make a new file system, we're going to use ext4 on this partition. If we wanted to then do an fdisk on it to see, hey, there's something that's probably wrong with this partition, I want to see if I can fix it, I have to unmount it first, which the command is umount to unmount. I tell it what I want to unmount, and then I can run fdisk on this drive. Now, do I expect you to know exactly how to do each one of these? No, I do not. I do expect you to know that fdisk is one of the commands, and parted was the other one for the two tools that we can utilize for this. And I do want you to know that mount and umount is available for mounting and unmounting drives. But you don't need to have to do this completely off the top of your head. And I highly recommend that you don't do this off the top of your head. This is one of those times that you bring in a buddy and then also do some research and make sure you're doing this correctly, because you can make some really bad mistakes and lose a lot of data. All right, so mounting those file systems. Once we have a partition, we need to mount it. In Windows, we mount it through letters, C, D, E, F, G, right? You see that quite often. But in Linux, we do not mount it to a letter, we mount it to a folder, a directory. So everything is mounted as a file, including our drives and our partitions, and we can mount this anywhere we want. Now, the mount point that we use is the directory we want. Now, by default, Linux does have a MNT mount point that it has, and it utilizes quite often when you automatically plug in things like jump drives and stuff like that to help with autoplay. But it doesn't mean that's where you have to mount your file. You can mount your file wherever you want. I do highly recommend mounting it into a system directory such as OPT or something like that, and not in your home directory unless you're the only user that's ever going to use that mount point. It all depends, again, on your point of view. Now, if I want to mount things temporarily, just for like one-time use, like a USB jump drive, then I can mount it by using sudo mount. I got to point to the directory of the device itself, and then where do I want to mount it? As I said, the MNT directory is one of the more popular places to mount a file. Just be aware it all depends on who has permissions here. And so we want to make sure that we understand who has permissions to these mounts. So sudo mount mounts this as root, and if it will be under mnt data for this directory. So if I change to mnt data, I will actually see that USB jump drive. Now when I'm done with it, I can see sudo umount of mount data, and I can unmount this directory as well. But remember, this command is temporary, and as soon as I reboot, it's gone. So how do I do things a little more permanent? Well, that's where fstab comes involved. fstab is the configuration file for file systems that lets you automatically mount things on boot. You'll notice this is where root and home directories are mounted every time you start your computer. There's lines in the fstab file, so please don't mess them up, that will auto mount certain files in here. Now, this is just one of the many ways to do mounting in Linux, but this is the built-in way for Linux, and that the CompTIA Linux Plus wants you to understand. So if you need to do a permanent mount, you do need to mount it in etc fstab. Now how does this work? Well, if you looked at etc fstab, there's a format. It tells us the file system itself, UUID. There's a UUID for the file system here, and that's the best practice because it doesn't change. Names can change, okay? So if you said /dev/SDB1 and you said that is what I want to mount, it will work. Just know that UUIDs are permanent. Think of UUIDs as unique identifiers for that system. Every time you plug in that device, it's going to always have the same UUID. So for instance, a jump drive will have the same UUID every time I plug it into a system. But it may not be the same mount point. Maybe I already am using SDB1 for a different jump drive, and I might get SDC1 for the next one. Okay, so UUIDs is the best practice, but if you ever need to mount something in a quick pinch, you can always use the name. UUIDs are better though. All right, now if I read this a little bit in depth, I have the UUID. I want to mount it to /data. Right in the root directory under a data folder. It's an ext4. I'm using the default options, and then I'm using a 02, which is for the dump and the pass. And these are pretty standard on here of everything you want to do. Now, if we want to, we can change the options on all of this. Sometimes I may want to mount it as read-only. Maybe I want to mount it as read-write. It depends on which options you want. There's a whole bunch of different things you can put in fstab. But again, you don't need to know exactly how to do this, except for you need to understand that fstab is for the permanent locations, and you probably should know that you can mount based off of UUID a unique identifier for that device itself. Now, FHS, the File System Hierarchy Standard, is the way that Linux likes to use for their system. So unlike Windows, we don't use C and D for drives. We have a unified directory structure, always starting with the root directory. And when I say root directory, it is viewed as the forward slash. Forward slash is root. So if you see the forward slash, don't say forward slash, say root. Well, that is root. Okay? And this is going to ensure consistent across all different types of Linux operating systems. It's one of the standards that every Linux operating system uses. Now, there are going to be a whole bunch of different types of directories. So some of the key directories that you should know for the exam, for instance, would be the root directory itself. This is the start of everything. You need to know that the /bin directory does exist, and these are our binary files. Bin is binary files. This is where ls comes from, cp, mv. All the basic commands that we use every day are normally stored in the bin directory. Now, some of the system binaries are going to be in the sbin directory, such as fdisk and makefilesystem. These are more complicated directories. These are normally not used by traditional users. Sbins are normally used 100% by root users. And you can look at those two directories on any Linux operating system and kind of see what the differences are and see the different commands in there. You'll notice there's a lot of binaries, and you'll notice a few that you'll recognize because some of these commands you've already learned. Etsy is a system-wide configuration. So it's etc, which is pronounced Etsy. So if I say go to your Etsy directory, that means go to the etc directory. Now, 9 times out of 10, this is the root directory. This is where everything for root-owned system files are going to be. So if you want to read or even write in this directory, you most likely will need to be able to be a root user. A few more directories for you. The /home directory. We already know this directory because your home directory is /home/username, otherwise known as the tilde, right? You get the /root directory. This is the home directory for the root user. So they kind of get their own home directory. While you have to stay in the home directory, root can have its own. It's in /root. Okay? /var is the variable directory. 9 times out of 10, you're coming here to look at a log. Okay? Var log is the most important location on the server that you should know about. It's where all the logs are. So when something breaks, what are you going to do? You're going to go check the log. You're going to go figure out what's going on by looking at var log. The temp directory does exist. This is for temporary files. Pretty much any user can use this directory. It's called the TMP directory. It's just like ctemp on Windows, except for it's a temp directory that is system-wide for, well, all users. Just be aware it is the temp directory and is designed to be temporary. The system may delete files out of here, and it's not meant to be your permanent storage location. We can continue on for installed software libraries and documentation. These are normally found in the user directory. Remember, this is where we will find our HTML, HTML help pages. This is where we also find our man pages. This is also where you're going to find some of the user installed software. All our devices will be in the DEV directory. This is where you're going to find it as the representation of the hardware. You're going to find all your boot systems, such as your grub file, which we have a whole section to talk about the grub file. This is where you're going to find all of the boot files. This is also where you're going to find those kernels. This is where all the system kernel binary files are going to be stored. Now there's a whole bunch of mount points here, and you can do it in MNT or media. It all depends on which type of operating system you're in. For example, on Ubuntu, we like to use the mount file quite often. But on Fedora, they love the media directory. It all depends on the flavor of the window manager that you're using and also what operating system you're using. Now, how do we troubleshoot storage issues? Because things will go wrong. You're going to need to know what tools you can use to fix the problem. The disk is full. Well, how do I know how much disk is being used? And that's called the disk free command. Disk free-h shows you in human readable terms how much space is free on all of our disks. And I do say human readable by capital or by H because without it, it just shows it to you in bits, which is a very big number that means nothing to me. But in human readable, it will start showing it to you in gigabytes, megabytes, terabytes, in very human readable terms. Okay? And it's really cool. You make sure you run these commands to understand what these do. Now, disk usage, on the other hand, can be run inside of a directory, and it will tell you what is using the space. So df-h only shows you the disk partitions and the mount points of what they're utilizing. du, on the other hand, can be, well, what in that partition is taking up the space. And you can go in there and type du-sh star, and it will tell you every directory and the size of that directory. So then you can start navigating to figure out, well, what's using up all of my space? So df and du are the two main commands to remember here. There's a new feature, not really new, there's a new concept for you that's called inode. So there could be an inode exhaustion issue. df-h says there's space, but you get no space left. You may have ran out of inodes. So inodes is a data structure that tracks the file itself. You may have millions of tiny files within a directory. If you do, you're going to run out of inodes. So you can use the command called diskfree-I for inodes and see how much inodes you have available. And think of these like memory addresses. You can only have so many houses on a street before we run out of numbers. Now, this is the same way that in a directory structure that we have too. Normally, what we do is we create separate, folder structures inside of our partition to help prevent inode exhaustion. But there is going to be still a limitation of how many files we can put on a file system. And so this is called inode exhaustion. And this is one of those really weird concepts to get around. And so I always try to remember it as I've got plenty of land for a house, but there is definitely going to be a limit of how many house numbers I can have available. So in order for me to change house numbers, I for one need a new street name or a new partition. I need something different so I can have a brand new set of numbers that I can use all over again. Now we can be very proactive with our management, and it's called quotas. So instead of for the disk to fill up, we can set up quotas. And I do highly recommend that we use quotas for our users, mainly to limit that we don't have users that just consume too much space or groups that consume too much space. So there are different ways that you can do quotas. You can do a soft limit where it starts warning people when they get close to their quota limit. You can do a hard limit where if they go past it, they just can't do anything else. They can't save any new files until they come below the hard limit quota. And some of the commands to keep in mind here would be the ed quota or the rep quota. Now, the ed quota is how we set the quotas versus rep quota is the report. So if you think about rep as report quota, it will help us see where people are. Now, these commands can be ran as the report quota can be ran as a user to see where they currently live in their quotas. All right, so there's a lot of information here, especially if you're not completely familiar with storage. Just be aware storage comes in a whole bunch of different formats, block files, objects. You use them every day, you just probably didn't know what they were called. Now we do use GPT partitions most of the time, but the older ones are MBR. Know why we upgraded. That's one of the big ones, especially with the 2 terabyte limit. That's a big one that they like to talk about. Know that LVM is more flexible, and they love it to be the be-all, but it's not the be-all. Know that it's physical volume groups, and logical volumes. They love to ask these questions on the CompTIA Linux Plus, especially with LVMs. Normally saying that they try to create an LV without creating a PV or VG to begin with. What went wrong? Well, they got to create the physical volume before they can create the volume group, before they can create the logical volume. That's something that they like to talk about. Now, the file system itself, know that ext4 is pretty common standard for desktops, and XFS and ZFS is definitely common for servers. Now, we use the make file system to format on a Linux operating system quite often. That's one of the tools that are going to be there. Now, we do like to mount things underneath the mount directory, or we can use the mount command or the umount to unmount. But if we wanted to make them more permanent, make sure you remember etcfs tab. Know the FHS, the file system hierarchy system. Make sure that you know what folder is normally used for what. Another one of those places that they love to question you on the Linux Plus. This is one of the biggest sections, just 32% of management of a Linux file system. And if you don't know where things belong, you're not going to be able to manage it. Again, there's still a ton more tools that we probably should know about. DFDU. I didn't even talk about IOStat, but we probably should do that. Make sure you know what an inode is. And in the book, make sure that you just know your tools. In order to really understand what these tools are and what they do, you need to run them. Go to your labs, run the tools, become familiar with it. Because guess what? I will see you in chapter 6.